In this episode, we move from the broad goal of business continuity into the more specific discipline of disaster recovery. Because keeping the business running during disruption is one challenge, and restoring technology and data to an acceptable state is another. Disaster recovery is where organizations prove that they can rebuild critical services after severe failures, cyber incidents, or operational disasters, and prove it in a way that is measurable and defensible. Beginners often think disaster recovery is simply having backups, but backups alone do not tell you how quickly you can restore, how much data you might lose, or whether the restored environment will actually be trustworthy. That is why clear targets matter, because targets transform vague hope into concrete commitments that can be engineered, tested, and improved. The core targets are Recovery Time Objective, RTO, and Recovery Point Objective, RPO, and they only become real when they are tested and supported by restoration evidence. When leaders understand these targets, they can align business expectations with technical realities and avoid painful surprises during crises. Recovery Time Objective, RTO, is a measure of time, and it answers a practical business question. How long can a specific service be unavailable before the impact becomes unacceptable? It is not the time you would like. It is the time the business can tolerate given revenue, safety, legal obligations, and operational constraints. An RTO is specific to a service or capability, which means different systems can and should have different targets, because not everything needs to be restored with the same urgency. Beginners sometimes assume the goal is to make every system come back immediately, but that is both unrealistic and expensive, and it can lead to a disaster recovery plan that is so complex it fails when needed. Leaders should treat RTO as a negotiation between business value and technical feasibility, grounded in the business impact analysis, BIA, work that identifies critical capabilities. If you set an RTO that is too aggressive for the resources and architecture you have, you end up with a plan that looks good on paper but collapses under real conditions. A realistic RTO is a promise you can keep, and keeping promises is the heart of trust. Recovery Point Objective, RPO, is a measure of data loss tolerance, and it answers a different but equally important question. How much data can you afford to lose and still operate safely and responsibly? RPO is usually expressed as a time window, such as losing the last hour of changes, and it is deeply tied to how often data is captured, replicated, or backed up. Beginners often think RPO is only about backups, but it is really about business reality, because losing even a few minutes of data can be unacceptable in systems that track financial transactions, safety events, or regulated records. Leaders should therefore ask what kinds of decisions or commitments depend on that data, and what the consequences are if the most recent portion disappears. RPO also connects to integrity and trust, because restoring older data can create reconciliation problems and customer disputes if the business cannot clearly explain what was lost and what was preserved. A mature organization sets RPO targets based on the value and sensitivity of data, not on the convenience of the backup schedule. When RPO is aligned to reality, the organization can plan its recovery approach without gambling its credibility. RTO and RPO should be designed together because time and data are intertwined in real recovery. If you want a very short RTO, you often need systems that can be brought online quickly, which may require redundancy and automation. If you want a very small RPO, you often need frequent data replication or continuous protection mechanisms that reduce how much can be lost. These goals can conflict with cost, complexity, and operational risk, because more replication and redundancy can increase attack surface and create new failure modes. Beginners sometimes treat these targets as independent, but leaders must understand that a short RTO with a large RPO could mean you restore quickly, but with stale data, which might break business processes. Conversely, a tiny RPO with a long RTO could mean your data is preserved precisely, but you cannot use it in time to meet customer commitments. Designing targets is therefore a balancing act that depends on the capability, the threat model, and the organization's tolerance for disruption. Leaders add value by making these trade-offs explicit rather than letting them be accidental outcomes of infrastructure choices. A common misunderstanding is treating disaster recovery as a purely technical concern, when it is actually a program that includes people, process, and evidence. People matter because recovery requires coordination, access, and clear authority to make changes quickly. Process matters because recovery steps must be repeatable, documented, and safe under pressure, not improvised differently by each responder. Evidence matters because during and after recovery, stakeholders will ask what was restored, when it was restored, and whether it is trustworthy, and those questions cannot be answered with confidence if the organization did not capture proof. Leaders should view disaster recovery targets as commitments that require governance, ownership, and periodic review because business dependencies evolve and so do threats. For example, a cyber incident can change recovery needs because you may need to restore from known good points and validate integrity before bringing systems back. Disaster recovery is not only about being able to restore, it is about being able to restore in a way that aligns with both business urgency and security confidence. Targets without process and evidence are just numbers. Testing is what makes targets real, because without testing, you do not know whether your RTO and RPO are achievable under the conditions that matter. Beginners sometimes think testing is disruptive and therefore optional, but the disruption of a planned test is small compared to the disruption of a failed recovery during a real disaster. Testing also reveals hidden dependencies, like an identity system needed to authenticate administrators, a network configuration required to reach storage, or a third-party service needed to re-establish integrations. Leaders should encourage testing that varies scenarios because different disruptions reveal different weak points. A simple storage failure is not the same as a ransomware event where integrity is uncertain, and your recovery plan must handle both. Testing should include not only whether systems can be restored, but whether the restored systems operate correctly, whether data is consistent, and whether monitoring shows stable behavior. When testing is done regularly, targets can be refined based on evidence, and the organization can invest in improvements that actually reduce recovery time and data loss. Restoration evidence is the often missed ingredient that turns recovery into something you can trust and defend. Evidence includes logs of recovery actions, proof of backup integrity checks, records of which backup sets were used, timestamps for restore points, and validation results that show systems and data behave as expected. Beginners sometimes assume that if the system is running, it must be fine, but running does not equal correct, and it definitely does not equal trustworthy after a serious incident. Restoration evidence helps answer questions like whether the restored environment includes the same vulnerabilities that enabled the incident, whether compromised credentials were rotated, and whether suspicious artifacts are absent. It also supports compliance and audit requirements, because many industries require proof that recovery processes are tested and that data protection commitments are met. Leaders should insist on evidence because it prevents disputes later, both internal and external, about what happened and what was restored. Evidence is also part of learning because it reveals what slowed recovery and what steps were fragile. When evidence is captured systematically, disaster recovery becomes a repeatable capability rather than a high-stress gamble. Another key point is that disaster recovery targets must reflect the difference between restoring availability and restoring trust, especially after security incidents. If an outage is caused by a benign failure, restoring quickly may be the primary goal. If an outage is caused by compromise, restoring quickly without validation can reintroduce the attacker or reintroduce corrupted data. Leaders should therefore ensure recovery plans include trust gates, meaning specific checks that must be satisfied before systems are considered safe for normal use. These checks might include verifying patch levels, confirming that access controls and credentials are corrected, ensuring that logging and monitoring are functioning, and validating that critical data has not been manipulated. Beginners sometimes see these gates as delays, but they are safeguards that prevent repeated incidents and protect customer trust. In practice, trust gates help executives make balanced decisions because they clarify what is needed to restore safely, not just quickly. Disaster recovery targets should therefore be designed with both speed and confidence in mind. Designing RTO and RPO also requires understanding which systems are upstream dependencies that must be restored early to enable other recoveries. Identity services, network core functions, and monitoring often act as foundational layers, because without them, teams may not be able to authenticate, coordinate, or observe what is happening. Beginners sometimes focus on restoring customer-facing applications first, only to discover those applications cannot function without identity, database services, or third-party connectivity. Leaders should ensure recovery sequencing is informed by dependency mapping, because recovery is a chain of enablement, not a set of independent tasks. This sequencing also affects targets, because an application's achievable RTO may depend on a supporting system's RTO. If upstream systems are slow to restore, downstream targets become unrealistic. Designing targets, therefore, includes designing a recovery order that makes sense and can be executed under stress. The more honest the dependency work, the more reliable the recovery targets become. A practical way to think about RTO is that it is not a single number, but a set of milestones that represent progressive restoration of capability. Some services may have a minimal viable mode that can be restored quickly, followed by a full mode that takes longer. For example, an organization might restore read-only access to certain records before restoring full write capabilities to protect integrity while enabling essential operations. This concept helps because it allows the business to keep functioning while deeper restoration continues, and it aligns naturally with the idea of continuity versus full recovery. Leaders should use milestone thinking to avoid unrealistic all-or-nothing expectations, because expecting full normalcy instantly often drives unsafe shortcuts. Milestones also make testing more precise because you can test whether each stage can be achieved within its target time. This staged approach makes disaster recovery more realistic and more aligned to business needs. It also supports safer operations when trust is uncertain, because you can restore in constrained modes while monitoring and verification continue. RPO design also benefits from honesty about how data is created and how it can be reconciled if some portion is lost. If you lose the last hour of transactions, can you rebuild them from other records, like external payment processor logs, customer confirmations, or manual records? If you lose recent updates to a customer database, can support teams reconstruct changes without creating additional errors? Beginners often treat data loss as a binary catastrophe, but in reality, some data can be reconstructed if processes exist, while other data cannot because it was never recorded elsewhere. Leaders should engage business stakeholders in these questions because they understand where truth originates and where alternate records exist. This is also where restoration evidence becomes crucial, because if the organization must reconcile lost data, it needs precise knowledge of the restore point and what time window is affected. RPO targets should reflect both tolerance for loss and ability to reconcile, because a small loss may still be unacceptable if it cannot be reconstructed accurately. When RPO is designed with reconciliation in mind, recovery becomes less chaotic. Testing should include not only whether recovery works, but whether recovery can be executed by the people who will actually do it, under conditions that resemble real stress. This includes verifying that access permissions are available, that documentation is clear, and that communication pathways exist if primary systems are down. Beginners sometimes assume the most skilled engineer will always be present, but disasters do not schedule themselves, and the recovery process must be executable by the team available at the time. Leaders should therefore treat testing as training, where the goal is to reveal gaps in knowledge, access, and coordination while the cost of failure is low. Testing also should validate evidence capture, because a recovery that succeeds technically but produces no records is still a failure in governance terms. When tests are run, results should be reviewed honestly and used to adjust targets or improve capability. A test that reveals your RTO is unrealistic is not a bad test. It is a valuable warning that prevents a future crisis. Mature organizations use tests to make promises they can keep. When you tie it all together, designing disaster recovery targets is about aligning urgency and data value with realistic capabilities, then proving those capabilities through testing and evidence. RTO expresses how quickly a service must return. RPO expresses how much data loss can be tolerated, and both targets must reflect real dependencies and real business consequences. Testing turns those targets into verified performance rather than optimistic assumptions, and restoration evidence turns recovery into something you can trust, defend, and improve. Leaders add value by making trade-offs explicit, ensuring that trust gates are included for security-related disruptions, and insisting on documentation and review that keep the program honest. Disaster recovery is not just an IT project. It is a trust commitment between the organization and the people it serves. When that commitment is designed with clarity and proven with evidence, the organization can recover from disruption with less chaos, less harm, and far more confidence.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.